Associative design is a parametric design technique using metric parameters to create an infinite number of variations. It is a technique based on associative geometry. Such geometries describe the relationship between various assemblies and constitute a design object as a mutually linked geometrical construction. Referencing the Chinese living culture and climatic performance, the north-south typology is the most popular one in the market. This geometric model provides longer south-facing width and natural ventilation from different orientations and tries to overcome the existing rectangular model. The inner corner of the L shape can be the private courtyard, while the outer corner becomes part of the shared collective space. The courtyard is formulated by putting several units in the plot. Generated by two identical rectangles, the plot transformed from pentagon to quadrilateral contains minimum one or generally two right angles, which are preferred to both construction and housing organization. By varying the size and configuration of the plot, the number of the neighbors sharing the same collective courtyard and the organization of the housing unit changes. Different FAR value and population density are created. The housing unit varies both in size and angle, therefore can accommodate different family structures, from single-person accommodation, nuclear family, to extended family, and offers various organizations for different income groups and individual preferences. The floor plan of the lower level gives the basis for growth above. At the same time, it creates upper courtyards and different routines for each apartment, which is different from the existing staircase home linkage. The courtyards act as the transition between private and public. Therefore, the street courtyard home routine is three-dimensionally created. The national regulation of providing 2 hours sunlight for each apartment in the specific day in winter is integrated in the geometric model. Certain distance and number of floors are automatically calculated. By applying the housing plot on site, this geometrical model shows how new plots are generated out of the existing ones. 3 existing site conditions are considered: angles less than 90 degrees, between 90 to 150, and finally between 150 to 180 degrees. 2 things are considered: the size of the polygon, which relates to the FAR value, population density and income group, as well as the orientation for each side in order to make sure that each apartment receives sufficient sunlight. Different simple strategies in accordance with the land value map are applied in order to generate the proper size and orientation of polygons to fulfill the economic requirements. As a scenario, the first growth completed when it contained approximately 600 people and 200 families according to the national regulation to the cluster scale. With the integration of water, car access roads, and pedestrian paths into the unit, the network of the path system and junctions are emerged and evaluated. The integration, which is used to estimate the frequency of use, mainly the pedestrian flow, has been calculated. Therefore, the width of the pedestrian and formation of the junction is determined. Parking is calculated to 0.6 to 1 car per family according to the plot size and housing standard located on the ground floor. To minimize walking distance, every unit has at least one side for parking, and this formulates the driveway. Different communal functions are placed to the most frequently used path according to the character of the path and the junction, and water is placed beside it to enforce the recognizability. The most accessible plot within the cluster becomes public space. According to the economic principle, the most popular path from the existing cluster will affect the land value. Therefore, the next stage of growth will be based on the new land value map. According to the size of the site and population, 6 steps of growth are taken. The final result consists of parking system, pedestrian network, water system, public spaces, and program distribution.